So here we are, SAT 22 for week 23. Let's take a look at our multiple choice question here. In the XY plane, a parabola has the vertex 9, comma, negative 14 and intersects the x-axis at 2 points. If the equation of the parabola is written in the form y is equal to ax squared plus bx plus c, where a, b, and c are constants, which of the following could be the value of a plus b plus c? Strange question. However, how did we do? Well, let's take a look at this pie graph here. You can see a big spike here at green. 57% of us said it was answer choice D. Answer choice D is in fact the correct answer here. So a bit over half of us got this one correct. And the other three answer choices are nearly evenly split between the other three. Let's say with a slight spike here at answer choice B, negative 19. I don't know what's up with that. Anyway, we said that this thing was roughly in a medium level question. You can see the biggest spike here at 3, maybe skewed a little bit towards the medium. All right, so let's dive into our solution. First question you might ask yourself, well, would Desmos help me out on this one? And I would say only slightly. I don't think that this question is entirely Desmosable. Could you make it work? But yeah, but it would take you a while and you'd have to get extremely lucky with your sliders. So first of all, the equation that it gives us, y is equal to ax squared plus bx plus c. This is the classic standard form of your parabola. Now, unfortunately, in standard form, it's not obvious what your vertex is. Remember, our vertex here is supposed to go through 9, negative 14. Now, there is a little formula. It's part of the quadratic formula, which would help you find the x-coordinates of the vertex. And that specifically is x is equal to negative b over 2a. Perhaps you could make that work. I think that that's kind of the wrong path, though. I would suggest instead using the vertex form, and the vertex form goes like this. Y is equal to an a times x minus h squared plus k. Again, this one is referred to as vertex form, and it's called vertex form because the vertex is given to us as h comma k. Now notice that the h already has the negative on it and the k doesn't. So the vertex here, h comma k, again, is equal to our vertex. And we already have the coordinates of our vertex, which is that 9, negative 14. So let's rewrite our vertex form using this 9, negative 14. So y is equal to still a little a times x, and it has the minus in there, even though the 9 is a positive number, squared. It's supposed to be plus my k value, but my k value is negative 14, so minus 14. Now, I think that where Desmos could come in handy is, let's say, for example, you didn't know your vertex form. How dare you? But maybe Desmos could help you investigate to try to figure out that particular equation. We'll see how to do that in just a second. But then also, what it's going to do is help you figure out a little something about your A. Speaking of A, I do want you to pick up on the fact that this A is the same exact A value for your standard form. So you're kind of part of the way there. But notice that also you don't know from this equation what the B and the C value is. So we'll have to figure out what that is all about here in a second too. So let's go over here to Desmos. And the first thing that I'm going to do is I'm going to type in the coordinates for the vertex so I can make sure that my equation goes through that point. Right, maybe throw a label on it, and of course it's down here. So in the second box here, I'll type in the equation with a little slider for a parentheses x minus 9, close parentheses, square it. Oh, oops, forgot my equal sign. Fixed. Okay, and then minus 14 here at the end of this thing, and add the slider And it does, in fact, go through that vertex as we anticipated. Now, here's, I think, where Desmos can kind of come in handy. As I said, if you didn't know what the vertex form was, maybe you can do a little investigation and shift this thing around, guess and check to see what that equation could possibly look like. I wouldn't suggest typing this in as y equals ax squared plus bx plus c as in standard form and try to fiddle with the a, the b, and the c so that you could try to get one of these numbers. And you'll see why at the very end of this when we see what the actual values of A and B and C turn out to be. You would have to really, really luck upon it, and it would take you way longer than you could possibly allot for this question. Anyway, so now what a good use of the Desmos would be is actually shifting around A and getting a handle for what A could possibly be. Because there is a key passage in the paragraph, and that key passage says that your parabola has to intersect the x-axis at 2 points. And you can see right now, our parabola is opening upwards, and it currently is intersecting the x-axis at 2 points. It's these two guys right here, those two x-intercepts. And if I slide this slider to the right, it keeps doing that. This thing looks like it's getting skinnier because it's vertically stretching, and those two x-intercepts are getting closer and closer together. But as soon as I make my a value, negative, notice that it no longer touches the x-axis. Negative leading coefficient, this negative a value, is going to make that parabola open downwards, and it's not going to touch the x-axis anymore. And of course, if it is a flat zero, we have ourselves a line because a times the whole quadratic part goes away, and then we just have y is equal to negative 14. So the biggest takeaway from this on the Desmos side is the understanding that a has to be a positive value. So keep that in mind. So I'm going to write that down here because this is important. A has to be greater than 0. Now, how do we get the A, the B, and the C? Especially since the vertex form doesn't give it to us. Well, what we do is we just transform the vertex form into standard form. We're going to make this guy look like that guy by just expanding it out and combining some like terms if there are any. Okay, so I'm going to rewrite the quadratic term here, expand this thing out like so. X minus 9 squared means x minus 9 times x minus 9, and then minus 14. It would be a mistake to just try to square both of these things inside of the parentheses, because you know what? That's not the way algebra and exponents work. Okay, so y is equal to a, and let's just use a little bit of foiling, and let me rewrite this because it looks like a 9. Okay, that's better. Doing a little bit of foiling, that was a really ugly mark there. X times x, x squared, then x times negative 9, negative 9x, do the same thing on the middle one, inside one, another 9x, and then negative 9 times negative 9 is a positive 81. And then bring down the minus 14. Combining these like terms, we'd have a negative 18 of them. Now, some of this, of course, would be shortcut by already knowing what vertex form is supposed to look like, and then also knowing how to expand out like the square of a binomial really quickly, because there's a pattern for that. And the pattern for that goes like this. A minus b squared is equal to the first one squared, whatever the sign is in the middle, and for us it was minus, so this one's minus. You multiply the two terms together and you double it, so it's 2 times a times b. And you can see that happened here, is that this is 9, negative 9 times this x, and then you double it, you get this negative 18. And then the last one is just plus the last term squared, which is our 81 that we got from the 9 squared. Anyway, I'm going to now distribute the a through the parentheses. So I have y is equal to ax squared minus 18ax plus 81a, and then I still have my 14. Now there's no other like terms for us to combine up. So now what we're going to do is we're going to compare this to the standard form. We're just going to write it right underneath it. Y is equal to ax squared. Those two things are exactly the same. Plus bx. So our x term has to be exactly the same. Plus c. The constant term has to be exactly the same. So I'm going to match these things up. First of all, our a is our a. Okay. Well, I mentioned that at the beginning, that a in both of these equations are exactly the same, whether it's in standard form or in vertex form. Okay, what about, let's say, the b? Well, the b is the number that is supposed to be attached to the linear term, the x term, and for us, that's negative 18a. So our b is equal to negative 18a. And notice that both of these things, the a and the b, are in terms of a. That's very handy. The same thing is about to happen for the c. So what is our c? Well, the c is supposed to be anything that's not attached to a variable. It's a constant term. And for us, that is both of these things here. It's the 81a minus 14. That's the stuff that's left over. There's no x or an x squared attached to it. So our c here is 81a minus 14. And what the problem wanted us to do was to add a, b, and c together. So let's do that now. Now we can combine some like terms because, as I mentioned, all of these things are in terms of a. So I can just add up all my a's. So first of all, I have an a minus 18a plus 81a, and then minus 14. So here, I'm going to combine these up together. First, I have 82 of these a's, and I'm going to subtract out 18 a's. And of course, you could just throw that into the calculator. Not gonna. Borrow the 1 here. That's going to make a 4. That's a 7. 64 a's. So this is 64a, and then bring down the minus 14. Okay, so how the heck did this possibly help us? Well, what the question was asking us again was that what is the sum of a, b, and c? And we were able to use a little bit of algebra to see that a, b, and c is exactly equal to just some expression in terms of a. So one of the things that we could do to find a plus b plus c is just plug something in for a. So let's say I try something pretty easy. Let's say I try a is equal to 1. If a is equal to 1, then we have 64 times 1 minus 14, which is equal to 64 minus 14 is 50. Now I think 50 is a problem. The reason why 50 is a problem is that all of our answers are negative numbers. Nothing's anywhere close. Okay, so then who knows? Maybe you try something like a is equal to 0. Make it even smaller. So 64 times 0 is equal to negative 14. Ooh, that's an answer choice. Is this possible? Can I choose answer choice C? And to me, I think that this should have been, let's say, the number one incorrect answer, but it wasn't. It was B. There must have been some other mistake that was going on here, some common mistake that I'm not picking up on. But anyway, I'm ruling this one out. And the reason why I'm ruling this one out is because the statement that we made based on our Desmos investigation, and that is that A has to be positive. If A is equal to 0 right here, it's not positive, and that leads you to negative 14. That's going to rule out this answer. It can't be that one. So that should already kind of push you in one direction as to what this answer is supposed to be. Anyway, I think that this was the wrong avenue to pick where we're just randomly selecting a number and plugging it in here. Instead, what we should have done is taken their answer choices, set it equal to ours, and see if we get an A value that makes sense. So I'm thinking that negative 12 is the correct answer because the negative 19 and the negative 23 are going in the wrong direction. Remember, if we stuck in the number 1, we got 50. This is implying that it has to be smaller than 1, but as we talked about, bigger than 0. So if I take my 64a minus 14 and set it equal to negative 12, I can solve this thing for a. Add the 14 over, I think that gives us a 2 is equal to 64a. Divide by 64, so 2 over 64 is 1 over 32. Tiny, sure, but still greater than 0. So if a was equal to 1 over 32, then a plus b plus c would be equal to negative 12, which is in fact our answer. All right, let me take this just one step further and actually verify this. Would you do this on the actual test? No, this would be taking way too long. And you would be, I guess, using that time at the expense of something that you could have gotten faster and easier. But I just wanted to kind of hit this home and show you what all of the A, the B, and the C have to be, and why it would have been so incredibly difficult to just kind of guess and check it. So we have our A value. Our A value is equal to 1 over 32. And then the B value, remember, is supposed to be negative 18 times that. So B is equal to negative 18 times 1 over 32. I'll just put that in Desmos. And then the C value is supposed to be 81A minus 14. 81 times 1 over 32 minus 14. Let's just throw all of those into Desmos. I can go up here to my A value and actually set it as 1 divided by 32. And notice that whenever I do, here's our parabola. It's a wide thing, right? And we do, in fact, have two x-intercepts. Who would have guessed those? Nobody. That's exactly who. And then if I have, what was it, negative 18 times a, negative 18, a, and it gives us that value. I'm going to go ahead and turn that into a fraction. It'll make it easier to type. And then my B, that was my B value. My C value was, was it like 81 minus 14, 81A? I think that's what it was. 81A, and then minus 14. And then we will turn that one into a fraction as well. So again, this is the entire reason why, take a look at those numbers, that you could not have just put in ax squared plus bx plus c with three little sliders and then guessed and checked those things to this level of accuracy in order to find the sum of these being, what was it, negative 12? Okay, so two last things. Let's go ahead and type in this equation as y is equal to, and then we had a 1 over 32 x squared. The x is in the wrong spot. Okay, x squared. So far, so good. And then it was minus 9 over 16, minus 9 divided by 16, arrow out of that x. And then the last one is a monstrous negative 367 divided by 32, and bam, you can see it snaps right there into place. And then one last thing, what if we were to just go ahead and add up that A, the B, and the C value? Remember, we should get one of our answer choices, which was that negative 12. So 1 divided by 32 minus 9 divided by 16, I think it was. Okay, so far, not so good. Oh, however, if we just subtract, is it subtract? Yeah, it's totally subtract. Subtract 367 and then divided that by 32. Oh, look, there's that nice negative 12. Whew. So honestly, if I were in your position and this was not coming to me like the standard form and using Desmos in order to get it, don't spend too much time on it at the expense of some other questions that you could have gotten far faster and far easier.